There are stones that have been lying quietly beneath our feet for millions of years, gray and silent on the outside, as if there is nothing worth noticing. But when they are opened, inside them may appear a sparkling crystal chamber, like a tiny universe that Earth has kept locked away in darkness. Welcome to Sleepy Drift into Knowing. On today's gentle journey, we will step into the world of geodes, stones that look ordinary on the outside, but carry a very deep story inside. A story of water, minerals, empty spaces, and time. A geode is not magic, and it is not something decorated from the outside. It is a real geological structure, often beginning as a hollow space inside rock. It may be an air bubble left behind in volcanic rock, or an empty space that formed inside sedimentary rock. Then, through tiny cracks, mineral-rich water slowly makes its way in, leaving behind layer after layer of Chalcedony, agate, quartz, calcite, or sometimes soft purple crystals like amethyst. Over a very long span of time, the inside of the stone grows little by little, until the darkness within the rock becomes a crystal chamber. Tonight, we will not simply look at geodes as beautiful objects. We will explore why they form, why some are hollow while others are almost completely solid, why their colors can be white, purple, yellow, brown, or blue, and why each geode is like a quiet recording made by Earth. If you truly enjoy gentle scientific journeys like this one, please quietly like the video and subscribe to the channel. And now, relax. Take a slow, deep breath and step with me inside a stone that seems, at first, completely ordinary. Before we go deeper into how geodes form, we need to look at them with a very calm eye. A geode is not the name of one separate gemstone, and it is not the name of one single crystal. A geode is a geological structure. The most important thing is that structure, a fairly hard outer shell of rock and an open space inside where minerals can settle, crystallize, and grow in silence. If you hold an uncut geode in your hand, you may feel disappointed for the first few seconds. It does not shine like a diamond. It is not clear like glass. It does not have dazzling colors on the surface either. Many geodes look, from the outside, just like rough stones, gray, brown, and sometimes bumpy, as if they have been worn down by time. But that ordinary appearance is exactly what makes a geode so memorable. Because its real beauty is not in an outer shell trying to get attention. It is in the tiny room hidden inside. Imagine that you are walking across a dry patch of ground or along the edge of a shallow creek bed. Beneath your feet is a stone that looks no different from all the others. It may feel a little heavier, a little rounder, or have an uneven surface, like the skin of a stone potato. But without knowing ahead of time, you would have very little reason to stop. Then that stone is cut open or carefully split apart. The moment the outer shell begins to open, something that seemed completely ordinary suddenly changes. Its inner walls may be covered with smooth chalcedony or bands of agate curling around like rings of time. And in the center, there may be quartz crystals growing inward. No one placed those crystals there. They are not decorations. They are the result of mineral-rich water, tiny cracks, chemistry, precipitation, empty space, and a great deal of time. The first thing to understand is that a geode is different from an ordinary solid stone because it has an inner cavity. That cavity may be clearly hollow, like a little room, but it may also have only a small open space left because crystals and minerals have grown until they have almost filled the whole interior. Some geodes, when opened, look like tiny caves with crystal points aiming toward the empty space in the middle. Others are almost solid, filled inside with chalcedony, agate, or massive quartz. So when we talk about geodes, we should not imagine that every one of them has to be completely hollow. Its nature is a structure that forms around a cavity, and then that cavity is lined or filled with mineral material, stage by stage. The outer layer of a geode is often the part that makes it easiest to overlook. It can be rough, uneven, opaque, and often not very colorful. But this outer layer is very important. It is the protective wall. Inside a larger mass of rock, as the surrounding rock is weakened by weathering, water, wind, temperature, and time, the tougher shell of the geode can help it survive longer. That is why many geodes are found separated from their parent rock, mixed into soil, lying in stream beds, or sitting in places where the surrounding rock has already been worn away. Seen that way, the rough outer shell is not meaningless. It is the closed door of a crystal room. When a geode is cut in half, we often see an arrangement that has a certain order to it. It is not always perfect, but it has geological logic. The layer closest to the shell may be Chalcedony, a microcrystalline form of silica, which means the crystals are too small for the naked eye to easily tell apart as separate grains. Chalcedony can form a smooth, slightly waxy foundation that may be grayish-white, pale blue, light brown, or many other shades. If the chalcedony layers show clear bands, people usually call it agate. Agate looks like soft lines curving through the inside of the stone, recording the moments when the mineral solution changed in composition or when precipitation conditions shifted. After that foundation layer, if open space remains, larger crystals may grow inward. This is why many geodes look as if they contain thousands of tiny points reaching toward the center. The crystals inside a geode often surprise people because they seem almost alive. But in reality, they grow according to very clear rules of matter. A crystal is an ordered structure at the atomic level. When the mineral components in water reach the right conditions, they can separate from the solution and attach to a surface that is already there. A new layer forms on top of an older layer. The crystal face expands in favorable directions. If there is plenty of space, the crystal has a better chance to show a clear shape. If the space is tight, the crystals crowd together, stay smaller, grow thicker, or form a tiny, sparkling layer. So the hollow part of a geode is not just empty space. It is the stage where mineral structure can take shape. There is one easy misunderstanding. Geodes do not always contain large, clear, brilliant crystals like the ones shown in advertisements. Many geodes are very simple. Inside, they may contain only small crystals that are cloudy white or pale gray. Some have a very fine sparkling surface called druze or druzy, meaning a layer of tiny crystals coating the surface. Others contain larger quartz crystals, calcite, dolomite, aragonite, or other minerals, depending on the environment where they formed. But even geodes with very little color still have scientific value because they show us how minerals enter an empty space and turn that space into a geological record. In science, beauty is not only found in strong color. Beauty is also found in process. If we look more slowly, a geode is wonderful evidence of Earth's patience. It begins with an empty space. In volcanic rock, that space may be a gas bubble trapped as lava cooled. In sedimentary rock, it may be related to hollow pockets, decayed material, or areas that were dissolved by water and became open spaces. After that, groundwater carrying silica, carbonate, or mineral ions moves through tiny pathways in the rock. Each time water enters and conditions change, a little material may be left behind. Not all at once, not quickly, just thin layer by thin layer, very small layer by very small layer, as if Earth were writing a line that only crystals could read. That is why a geode should not be understood as something created in a single moment. It is the result of a chain of conditions. There needs to be a cavity. There needs to be a source of minerals. There needs to be water or some kind of solution capable of carrying material. There needs to be time for minerals to settle. There needs to be an environment stable enough that the crystals are not destroyed as soon as they form. If even one of those conditions is missing, the geode will not take the form we see. An empty cavity without mineral-rich water is just a space. Mineral-rich water without a cavity may deposit minerals somewhere else. A geode is the meeting point of many small conditions, and that meeting is what creates a sense of wonder, while still belonging completely to science. When we say that the inside of a geode is like a small universe, we do not mean it in a mystical way. We mean it as an image. Because inside a cavity, barely an inch or two across, or only a few centimeters wide, there may be a foundation layer, bands, crystal faces, darkness, reflected light, and a feeling of depth. If you bring your eyes close to a quartz geode, the tiny crystal points may look like mountains made of glass. If you look into an agate geode, the bands may look like a map of ancient water. If you look into an amethyst geode, the purple inside may remind you of a sunset held inside stone. But all those images return to one simple truth. The outside of the stone may look ordinary, while the inside is the result of a very long history that the naked eye could never guess. Another very important point is that a geode is not the same as a single crystal. A separate quartz crystal can be described by its chemical formula, its crystal structure, and the shape of its surface. But a geode is a small system. It has a shell, a lining, a cavity, several stages of mineral formation, and sometimes several kinds of crystals existing together. If a crystal is a sentence, then a geode is a paragraph. It does not only answer the question, "What mineral is this?" It also leads to deeper questions. Where did this cavity come from? How did water move through it? Which minerals arrived first? Which crystals came later? Some geodes are small, about the size of a golf ball, cool and heavy in the palm of your hand. Some are larger, and when they are cut in half, they can sit on a table like two stone bowls full of light. There are also very large crystal cavities in nature, large enough for people to walk inside, although we need to carefully distinguish between ordinary small geodes, nodules, thunder eggs, and giant crystal caves. Whether small or large, the shared idea remains the same. The inner cavity became a place where minerals could reveal themselves. Outside is the rock shell. Inside is space. Mineral-rich water passes through. Crystals grow, and time quietly finishes the work. When a geode is almost completely filled, many people may think it is less interesting than a hollow geode. But from a scientific point of view, that is not true. An almost solid geode may show that mineral deposition continued for a longer time, or that the original cavity was smaller, or that more material entered the space. If the cut surface has agate layers, it may record several stages of change in the solution. If the inside is massive quartz, it may show that silica had the right conditions to fill most of the space. A hollow geode, with crystals pointing toward the center, on the other hand, shows us that open space remained for the crystals to grow more freely. These two types are not a case of one being beautiful and the other being bad. They are two different results of the same principle. An empty space inside rock became a place where mineral history was preserved. We also need to separate geodes from explanations that are too simple or too mystical. A geode can make a room more beautiful, can make a viewer feel calm, and can create the feeling of a secret being opened. But in scientific language, its clearest value is in geology, mineralogy, education, and aesthetics. It does not need to be given mystical powers in order to be special. In fact, when we understand how it forms, a geode becomes even more remarkable. No hand arranged each crystal. only water moving through cracks, dissolved minerals, changing chemical conditions, surfaces where crystals could attach, and enough time for silence to become shape. If you have ever seen a polished geode in a shop, remember that its beauty began with a very rough process. It was not born in a glass display case. It was born inside rock, in soil, in sedimentary layers, in old lava flows, in dark spaces that humans could not see. Before it was opened, it may have been mixed in with thousands of other stones. That contrast is what gives geodes such a strong pull. The outside promises almost nothing, while the inside reveals an order that feels strangely delicate. An ordinary stone, with the right empty space and the right flow of mineral-rich water passing through it, can become a small room of crystals. Inside a geode, the direction of crystal growth is also worth noticing. The crystals usually start from the cavity walls and grow inward. This happens because the cavity wall is the surface where mineral material first begins to attach. As atoms or ions from the solution connect to that surface, the crystal grows into the space that is still available. If the cavity remains open, the crystal can extend farther. If the cavity gradually fills, the crystals eventually meet, crowd into one another, or stop growing. When we look at a cut geode, we can see traces of that growth. The outer wall is not only a boundary, it is where everything begins. The hollow center is not only empty space, it is the place the growth is moving toward. This inward-pointing structure is what makes a geode feel like a small world built from the outside in. There is a beautiful truth here that is easy to miss. The empty space inside a geode is not a lack. It is the condition that allows beauty to happen. In everyday life, we often think of empty space as something unfinished. But in a geode, without empty space, crystals would have a much harder time growing into visible form. The cavity allows crystal faces to open. The cavity gives growth a direction. The cavity gives crystals a place to sparkle when light finally enters after millions of years of darkness. So when we look at a geode, we are not only looking at minerals, we are also looking at the role of space. Earth does not create beauty only through matter. Sometimes it creates beauty by leaving the right empty place at the right time in the right setting, and then letting time do the rest. A geode also reminds us that rock is not always motionless in a simple sense. Of course, rock is not alive like plants or animals, but within rock, there is still a history of movement. Lava once flowed. Water once seeped through. Minerals once dissolved. Layers once precipitated. Rock layers were once buried, lifted, cracked, and weathered. A geode lies still before us, but to reach that shape, it has passed through a very long story. Its present silence is the result of many movements that have ended, or that still continue very slowly. When we say a geode is a stone with a universe inside, we mean that within something small, there are traces of something much larger. The water cycle, the chemistry of silica, temperature, pressure, geological time, and the endurance of the rock shell. Not every geode is easy to recognize from the outside. Some people look for geodes by their round or oval shape, rough surface, weight that feels a little lighter than a solid rock of the same size, or a slightly different sound when tapped gently. But those signs are not absolute rules. Some stones look very promising and have no beautiful cavity inside. Some ugly stones open to reveal an unexpected scene. This is what makes geodes different from many decorative objects chosen by their surface. With a geode, the moment of real discovery often comes after it is opened. And that moment is very close to the spirit of science. We observe, make a hypothesis, test it, and then accept what nature shows us, instead of trusting only appearances. From an educational point of view, a geode is one of the simplest ways to step into mineralogy. It helps us see water entering rock, minerals settling out, crystals growing, bands forming, and empty space becoming a place that preserves history. With the same geode, a beginner may see surprise, a collector may notice completeness and natural color, and a geologist may ask questions about the environment where it formed. It is easy to look at, but it also has depth. It is beautiful, and it can be explained by science. Now, let us return to the image at the beginning, a stone lying quietly beneath your feet, not glowing, not calling its own name, not revealing anything on the surface. If we walk past it, it remains silent. If we pick it up, it is still only a rough stone. But if we open it, we see what the darkness has kept. We see layers of minerals placed down by water. We see crystals growing from the cavity wall, like a tiny forest made of silica. We see agate curving into bands like frozen time. And we understand the core truth of a geode. It is an ordinary stone on the outside, but inside, it is a room built by Earth from chemistry, water, and time. From here, the next natural question is no longer how beautiful a geode is, but how Earth can create one. The beauty inside needs an origin, a path for water to enter, minerals to be carried along, and then be left behind at the right moment. It needs small conditions repeated again and again over a long period of time. Once we understand what a geode is, we can go deeper into how it is born. And the deeper we go, the more clearly we see that a stone does not need to be brilliant on the outside in order to hold an astonishing history within. If, in the previous part, we saw a geode as a stone with a secret room inside, now let us slow down one step and ask where that room begins. In geology, beauty does not appear just because a rock suddenly becomes special. It needs conditions, it needs space, it needs material. And with a geode, the starting point is usually not a crystal, but a very small, empty space inside the rock. That empty space can form in volcanic rock. When lava is still hot, gas can get trapped inside the flowing molten material. As the lava cools and hardens, those gas bubbles become hollow cavities. At first, there is nothing sparkling inside them. They are only dark rooms locked inside stone. But those empty rooms are exactly what make a very long story possible. If mineral-rich water later finds its way in through tiny cracks, that hollow cavity can become the place where crystals begin to grow. Empty spaces can also appear in sedimentary rock. In layers of limestone, shale, or ancient sedimentary rock, some of the material can dissolve, break down, or slowly be replaced. When the old material disappears, it leaves behind a small chamber. That chamber does not need to be beautiful. It does not need to be perfectly round. It does not need to look like a glass jar. It only needs enough space for water to enter and for minerals to have a place to cling to. That is the most important point. Without an empty space, a geode has no room in which to form. But an empty space alone is not enough. A hollow cavity inside rock can exist for a very long time without creating any noticeable crystals. The next character in the story has to appear: water. Not noisy water flowing across the surface of the ground, but groundwater, seepage water, water moving through rock very slowly. As water passes through rock layers, it can dissolve small amounts of minerals. It can carry silica, carbonate, calcium, iron, and many other mineral ions, depending on the kind of rock it has passed through. A drop of water like that may look weak, but in geology, something tiny, repeated for long enough, can create a major result. Imagine a drop of water moving through the darkness of stone. It makes no sound, It does not glow. It only carries a little dissolved mineral material. When that drop of water enters a hollow chamber, the conditions inside the chamber may be different from the place it just came from. The temperature may change. The acidity or alkalinity may change. The concentration of minerals may reach a level where they can no longer remain stable in the water. At that point, part of the material begins to separate from the solution and attach to the chamber walls. This is a very important step. A geode is not filled from the outside. It is built from the inside, layer by layer, with extremely thin layers of mineral material. The first layer inside many geodes is often chalcedony, a very fine microcrystalline form of silica. The crystals in chalcedony are so small that the naked eye can barely distinguish individual grains. Because of that, this layer can look smooth, slightly waxy, grayish-white, pale blue, light brown, or many other shades. If the chalcedony layers form clear bands, we usually call that agate. Agate bands are not patterns painted onto the stone. They are traces of many separate episodes of mineral-rich solution passing through, each one possibly a little different in composition, deposition speed, or chemical conditions. After that smooth foundation layer, if the chamber still has open space, larger crystals can develop. This is when a geode gradually takes on its familiar look, crystals growing from the chamber walls toward the center. Quartz is a very common mineral in geodes. Calcite can also appear. Some geodes have a surface covered with countless tiny crystals, giving the impression that the inside has been coated with a sparkling mist. Others have clearer, longer crystals, with flat faces that reflect light. But even when their shapes are different, the principle remains the same. Crystals need a surface to start from, and they need open space to keep growing. This also explains why no two geodes are exactly alike. Two hollow chambers may begin in fairly similar ways, but if different water moves through them, the results will be different. One chamber may receive a lot of silica and form quartz. Another chamber may contain calcite. One chamber may be lined with clearly banded agate. Another may have only a cloudy white layer and very small crystals. Some geodes still have a beautiful hollow center. Others are almost completely filled with minerals. A geode is not a product cast from a mold. It is the unique record of one place, one flow of mineral-rich water, and one chain of conditions that took place inside rock. If the chamber is almost completely filled, the internal structure may look more like a solid nodule than the familiar hollow geode. If the chamber remains open, crystals have space to grow into small points facing the center. So when a geode is opened, what we see is different levels of completion within the same process. Some look like tiny caves. Some look like banded stones. Some have only a few crystals. Others sparkle densely from wall to wall. We should not rush to assume that a hollow geode is always better than a solid one, or that a colorful geode always has more scientific value than a pale one. Each one is its own result of water, minerals, and time. The three most important elements that create a geode are empty space, mineral-rich water, and time. Empty space provides a place for crystals to grow. Mineral-rich water supplies the material. Time allows that material to accumulate, arrange itself, and crystallize. If there is empty space but no mineral-rich water, the chamber is only a dark hollow inside the rock. If there is mineral-rich water but no empty space, crystals have a hard time forming a sparkling room. If both are present but there is not enough time, the process may leave only thin layers or unfinished traces. A geode, therefore, is a very precise meeting between space, matter, and time. In everyday life, we often think of time in days, months, or years. But geology works to a very different rhythm. A thin mineral layer may form through many separate episodes of water passing through. Those episodes may be separated by very long periods. The process does not necessarily happen continuously, like a machine running non-stop. It may begin, stop, and then continue when conditions change. One episode of water leaves behind a smooth silica layer. Another adds a banded layer. A later stage may allow larger crystals to develop. So inside a geode, there is not just one event. There are many small chapters of the same history. A geode can be seen as a chemical diary that is not written with words. The first Chalcedony layer tells us that silica was once present and precipitated on the chamber walls. The agate bands tell us that conditions once changed in repeated rhythms. The quartz crystals tell us that the chamber still had space for crystals to grow freely. If calcite is present, it points to a different stage or a different mineralizing environment. If there are yellow, red, or brown tones caused by iron compounds, we see additional traces of tiny impurities within the geological system. Each layer does more than make the geode more beautiful. It also allows the stone to be read like a record of nature. In volcanic rock, the story can begin with gas bubbles trapped inside lava. When the rock hardens, those gas bubbles become voids. Later, water rich in silica or other minerals seeps in. Minerals attach to the walls of the cavity, then form a lining and crystals. Something that was once a temporary gas bubble in hot lava can become a lasting crystal room. This is one of geology's most beautiful images. Emptiness is preserved, heat cools down, and water quietly turns that empty space into a place of order and light. In sedimentary rock, the story is usually quieter. Layers of limestone, shale, and ancient sediment can contain nodules or hollow cavities. Some of the material dissolves or is replaced, and then mineral-rich water enters. Silica can precipitate as chalcedony, creating an inner lining. Over time, this shell may become more durable than the surrounding rock. When the host rock is weathered by rain, flowing water, temperature changes, and time, the geode can be released. That is why many geodes are found in soil, in stream beds, or in places where the surrounding rock has been worn away. This reminds us that a geode lying on the ground today was not necessarily born right there. It may have formed in a deeper or more distant rock layer, and then nature brought it into the light. Rain softens the soil. Flowing water carries away smaller material. The surrounding rock cracks and breaks apart, and the geode, thanks to its harder outer shell, may remain behind, like a memory grain from an older rock layer. When someone picks it up, they are not just holding a stone. They are holding what remains of a geological environment that changed long before humans were present. One point should be made clear. A geode does not form by being strongly squeezed until it becomes beautiful. Some minerals do require special pressure and temperature conditions, but with geodes, the central factors are the hollow chamber and the mineral-rich solution entering that chamber. Of course, all rocks exist within the pressure and temperature conditions of their geological environment, but the distinctive beauty of a geode comes from minerals gradually lining the inner walls. It is not carved from the outside in, it is built up from the inside out, through repeated episodes of mineral-rich water. Put simply, a geode is not decorated, it is grown. The direction in which the crystals grow also tells a very clear story. Crystals usually begin on the chamber wall, because that is where the minerals first attach. From that surface, they grow into the remaining open space. If the chamber is wide and the conditions are stable, the crystals may become longer and show clearer faces. If the chamber is narrow, the crystals may be shorter or crowded together into a small, sparkling layer. The chamber wall is like the starting point of a crystal forest. The hollow center is the space the crystals grow toward. When we look at a cut geode, we are looking at growth direction recorded in mineral form. Not every hollow cavity in rock becomes a beautiful geode. Some chambers do not receive enough mineral material. Some are destroyed before crystals can grow. Some are filled with material that does not create clear crystal faces. Some sit in a chemical environment that is not favorable. That is why a beautiful geode is not something that happens everywhere. It is the result of a fairly delicate chain of conditions. The hollow cavity survives long enough. Mineral-rich water follows the right path. The dissolved material is suitable, and the environment remains stable enough that the mineral layers are not destroyed as soon as they form. A geode can also continue to change after its first stage of formation. New water can pass through, new minerals can be added. Some colors may appear because of natural impurities, such as iron compounds creating yellow, brown, or red tones in some cases. But it is also important to remember that many geodes sold on the market may have been cut, polished, cleaned, or even dyed. Those treatments can make a specimen more eye-catching, but they are not part of the original geological story. When we study geodes, we should separate the natural beauty formed inside the rock from the appearance humans may enhance later. There is something very quiet about this process. The most beautiful part of a geode is often created in darkness. Crystals do not need sunlight to grow inside a rock chamber. They need a mineral solution, a surface, chemical conditions, and time. A flower needs light to live, but crystals inside a geode can grow in a completely sealed place. No one sees them while they are forming. There is no noise. There are no bright colors showing on the outside. There are only chemical laws working very slowly until one day the stone is opened and the darkness inside meets light for the first time. That is why, when a geologist looks at a geode, they do not only ask whether it is beautiful. They may ask what kind of rock it formed in, where the original hollow chamber came from, whether the lining is Chalcedony or Agate, whether the crystals are quartz or calcite, whether the bands are continuous, and what geological environment the specimen came from. Those questions turn a geode from a decorative object into evidence. It shows that water once moved through rock. It shows that minerals were once transported. It shows that time left its traces, not in words, but in layers, bands, and crystals. If we return to the image of a tiny drop of water moving through dark stone, we can see that it is no longer as small as it seemed at first. It is the carrier of material. It brings minerals into an empty room. It leaves behind a thin layer. Then another drop comes, another seepage flow comes, another set of conditions arrives. Over many, many times, the inner surface of the chamber changes. The empty space gradually gains a lining. The lining gradually gains bands. The bands gradually accompany crystals, and the crystals gradually turn darkness into a place with form. This is how a geode is made. Not loudly, not quickly, not with any need for a dazzling exterior, but simply through the right process repeated over enough time. And that is why the geode becomes such a powerful image of hidden beauty inside something ordinary. It does not show off on the surface right away. It lets a rough outer shell protect what lies deeper within. It lets water do the work of carrying. It lets minerals do the work of building. It lets time do the work of completion. When the stone is finally opened, we are not seeing a miracle separated from science. We are seeing science become so beautiful that it feels like a miracle. A hollow space inside rock, through mineral-rich water and time, has become a tiny crystal universe. So if we look at a geode only as a beautiful stone, we are seeing only the final part of the story. The more important part lies in the journey before that. An empty space is created. Water enters, minerals precipitate, a smooth layer forms, crystals grow, the surrounding rock weathers away, and then the geode is brought into the light. That entire process serves one idea. The outside may look so ordinary that it is overlooked, but inside, Earth has quietly built a crystal room from water, minerals, and time. From this point on, now that we understand a geode begins with an empty space and is slowly grown by mineral-rich water, we can open the door inside it more carefully. What makes a geode different from an ordinary rock is not only whether it is hollow or not. What makes it memorable is that the chamber inside can hold a tiny mineral gallery. The walls of that room may be lined with chalcedony, smooth and waxy. The rock walls may carry bands of agate, curving around like layers of time. On that surface, quartz may grow into clear or milky white crystal points. In other geodes, calcite forms crystal faces that look completely different, softer in the way they catch the light, sometimes white, pale yellow, honey-colored, or almost transparent. And in amethyst geodes, purple appears like a very old sunset, preserved inside the rock through chemistry and natural radiation. The most common mineral in many geodes is quartz. Quartz is mainly made of silicon dioxide, a compound that is very common in Earth's crust. It is relatively hard, it resists weathering better than many softer minerals, and it can form clear crystals if it has enough space. When we look into a quartz geode, we often see crystals growing from the chamber walls toward the center. They may be as clear as ice, cloudy white like milk, or slightly smoky, depending on the conditions and tiny impurities. If the crystals are large, we can see sparkling flat faces. If the crystals are very small, the inner surface may look as if it has been coated with sugar, frost, or a layer of tiny points of light. But quartz inside a geode does not always begin right away as large crystal points. Many geodes have chalcedony as their first lining. Chalcedony also belongs to the silica family, but its crystals are extremely small, often microscopic or even smaller, so the naked eye cannot see individual crystals. Because of that, chalcedony feels smoother, denser, and less angular than large crystal quartz. It is like the quiet foundation layer of the stone room. If large quartz crystals are the crystal columns in the center, then chalcedony is the smooth wall layer that prepared the space for everything that came afterward. When chalcedony forms clearly banded layers, we call it agate. Agate is not a single color. It is a layered arrangement. Those bands may be white, gray, brown, pale yellow, light red, or many other shades depending on impurities and formation conditions. The important point is that these lines are not random decoration. They are traces of many episodes of mineral-rich solution moving through the hollow chamber. Each time water brought material in, a new layer could be left behind. When the composition of the solution changed, when the speed of precipitation changed, or when the impurities changed, the new layer could differ from the old one. That is why agate inside a geode is like a notebook written in bands of stone. Some geodes, when opened, do not overwhelm us with large crystals, but with very calm agate lines. Those layers run around the chamber walls, sometimes parallel, sometimes curving, sometimes wrapping around an open space in the middle. If we look at them for a while, we see that their beauty is not in brightness, but in order. One layer, then another, then another. Earth did not draw it with a pen. Mineral-rich water wrote it through repetition. These bands are what make a geode clear evidence that inner beauty does not arrive all at once. It is built through many, very slow rhythms. In some geodes, the center is covered with druzy crystals, meaning very small crystals, usually quartz, growing densely across the surface. When light touches this druzy layer, it can sparkle like snow under moonlight. This is a very interesting form because each crystal may be so small that we do not notice any single one by itself, but together the whole group creates a gentle shining effect. It reminds us that the beauty of a geode does not always need large crystals. Sometimes, all it takes is thousands of tiny crystal faces, each turned in a slightly different direction, for the inside of the stone to feel like a miniature starry sky. If the inner chamber is wider, the crystals have more room to develop. Then the crystal faces may become clearer and the shapes easier to recognize. But space is not the only factor. Crystals also need the right solution and enough time. If the mineral solution changes too quickly, if material is lacking, or if the chamber fills too early, the crystals may stay small, crowded, or unable to develop a clear shape. So, inside a geode, crystal form is the result of a balance between space, material, precipitation speed, and environmental stability. Calcite is another mineral that can appear inside a geode. Calcite is mainly made of calcium carbonate, unlike quartz, which is silicon dioxide. That chemical difference gives calcite different properties and different crystal forms. Calcite is softer than quartz, reacts more easily to weak acid, and can form transparent, white, pale yellow, honey brown, or gently colored crystals. When calcite sits inside a geode, the inner room feels different from a quartz geode. The light reflects differently. The crystal faces are different. The chemical story is different as well. This reminds us that geodes are not limited to only one type of mineral. A geode is a chamber that different minerals can use as a place to crystallize. Some geodes may also contain dolomite, aragonite, or other minerals. Aragonite and calcite are both forms of calcium carbonate, but they have different crystal structures. Dolomite contains calcium magnesium carbonate. Under the right conditions, these minerals can appear inside geode chambers or similar hollow structures. In some specimens, metallic minerals such as pyrite, hematite, or sulfides may also be found, although not every geode contains them. This makes the universe inside a geode much richer. From the outside, it may only look like a rough stone shell, but inside, it can hold a multi-stage mineral history. Amethyst is one of the most loved types of geode because of its purple color. But it is important to say this accurately. Amethyst is not a completely different mineral from quartz. It is purple quartz. That purple color is connected to a very small amount of iron inside the crystal structure and the effect of natural radiation over time, which creates color centers within the crystal. So when we look at an amethyst geode, we are not just looking at a beautiful color. We are looking at quartz that formed under conditions special enough for purple to appear. That purple may be pale, like lavender, deep, like wine, or uneven from one area to another within the same chamber. We should not say that every purple geode is natural, or that every bright color truly reflects geological history. Some geodes on the market may have been dyed to look more eye-catching, but in natural amethyst, the purple color is truly part of the mineralogical story. It shows that trace impurities and natural radiation conditions can change the way a crystal absorbs light. Just a very tiny amount within the atomic structure can be enough to turn a stone from colorless to purple. That is what makes an amethyst geode special. Inside a rough stone, chemistry at a very small scale can create a very powerful visual feeling. Some geodes also contain water trapped inside them. Specimens like this are often called anhydro when liquid is preserved inside a chamber or an inclusion. Not every geode contains ancient water, and we should not imagine that every one holds a tiny lake. But in some cases, liquid can be sealed inside a mineral or within a very small cavity, sometimes with an air bubble that can move when the specimen is turned. This detail is fascinating because it makes a geode an object that not only preserves crystals, but can also preserve traces of the liquid connected to its formation. Inside a geode, there can be many different generations of minerals. The outermost inner layer may form first, then another layer covers it, and crystals grow afterward. One generation of minerals may stop forming because conditions change. After a long time, a new solution may enter and create additional minerals. If we look closely, We may see one layer cutting across another, one crystal sitting on an earlier foundation, one color covering another. A geode, therefore, is not always a simple story from beginning to end. It is like a room renovated across many periods, but the only workers are mineral-rich water and time. The outer lining and the innermost crystals do not have to be the same mineral. This is a very important point. A geode may have a chalcedony or agate layer close to the wall, with larger quartz crystals inside. It may also have a carbonate layer, or calcite crystals, that developed after a silica stage. Changes in minerals show that the solution passing through the chamber was not always the same. The early water may have been rich in silica. A later stage may have changed in composition. Acidity or alkalinity, temperature, material source, and the surrounding rock can all have an influence. So a cross-section of a geode can sometimes be a map of several chemical environments following one another. If we imagine a geode as a very small exhibition room, then chalcedony is the smooth wall layer, agate is the banded pattern on the wall, quartz is the crystal towers growing from the floor and ceiling, calcite is a bright structure with a different geometry, and amethyst is the purple version of quartz when the trace conditions are right. This comparison helps us picture it more easily, but we should remember that no hand decorated that room. Every display piece inside it has a chemical and geological reason. Nothing was placed there just to look beautiful. Everything was born in place from the mineral solution that entered the hollow space. One interesting point is that a geode can be very beautiful even when its minerals are not rare. Quartz is a common mineral, and chalcedony is not something that appears in only a few places on the planet. But when they sit inside a sealed chamber, grow toward the center, and create layers, bands, and crystal faces, they become special. This is a subtle lesson from geology. Familiar materials, under the right conditions, can create astonishing structures. A geode does not need rare ingredients to be captivating. It needs a formation story beautiful enough to hold our attention. The richness inside geodes also helps explain why collectors often like to open or cut them. When the shell is still whole, we can only guess. We can rely on shape, weight, surface texture, or geological origin, but we cannot be completely certain. One stone may open to reveal a simple layer of white quartz, another may contain many layers of agate, another may hold calcite or amethyst. The moment a geode is opened is the moment the data appears. It feels like discovery, but it also has a clear scientific quality. Before observation, we only have a hypothesis. After the stone is opened, the specimen answers for itself. Inside a geode, order and uncertainty always exist together. The order lies in crystal structure. Quartz has its own atomic arrangement. Calcite has its own crystal system. Chalcedony has its own microcrystalline organization. But uncertainty lies in the shape of the chamber, the path of the water, the changing solution, tiny impurities, deposition speed, and interruptions across time. That is why a geode has both rules and uniqueness. It is not a chaotic mass, but it is also not a product made identically over and over again. It is a place where natural laws meet the individuality of each environment. That is why the inside of a geode can hold our attention for a long time. We may begin with a simple reaction, "It is so beautiful." But if we stay with it a little longer, we see more layers of meaning. We see chalcedony as a smooth foundation. We see agate as the history of each rhythm of water. We see quartz as the geometry of silica. We see calcite as a different chemical pathway. We see amethyst as purple, created by trace elements and natural radiation. We see druzy as countless tiny crystals creating light together. None of these things stands apart from the others. Together, they make one truth clear. Inside a geode is a small mineral universe built from very real things. If we had to choose one image to keep, imagine a stone room with no windows, sealed inside the earth. At first, that room is empty. Then water passes through and leaves behind a smooth wall layer. Over many more visits, the wall gains bands. Then crystals grow out, not to perform for anyone, but because atoms and ions have found stable positions in their structures. In one place, future light will meet quartz. In another, it will meet calcite. In another, it will meet the purple of amethyst. But throughout the entire time it is forming, that room remains dark. The beauty is made before anyone sees it. When we understand what is inside a geode, we also understand why we should not judge it only by brightness. A geode with soft color, small crystals, and thin bands can still tell a very clear story about water and minerals. A geode that looks extremely bright may be beautiful as decoration, but we need to know whether that color is natural or treated. A milky white geode may look modest, but it can preserve the honest beauty of silica precipitation. An amethyst geode may fascinate us, but its beauty becomes even more valuable when we understand that it is quartz colored by tiny natural conditions at the crystal level. From the outside, a geode is often silent. From the inside, it speaks through minerals. Chalcedony speaks through smoothness. Agate speaks through layers. Quartz speaks through crystal faces. Calcite speaks through a different geometry. Amethyst speaks through the purple of quartz. Druzy speaks through the light of thousands of tiny crystals. Each voice is different, but together they tell one message. Something ordinary on the outside can hold a deep, slow, history-rich structure within. And when we put everything together, a geode is no longer just a stone split open for decoration. It becomes a small geological space where many minerals can appear one after another. The chamber wall may be lined with smooth silica. Banded layers may record changes in the solution. Crystals may grow according to their atomic structures. Colors may come from impurities, color centers, or different minerals. A little ancient water may be trapped in special cases. Some crystals may be as small as shining dust, while others may be as clear as tower points. All of it serves one deep feeling. Inside a stone that seems ordinary, Earth has quietly built a mineral room, and no two are exactly alike. After looking at the minerals inside a geode, we naturally want to ask a very simple but very important question. Why do they have color? Why are some geodes soft white like milk, some purple like a sunset, some golden brown like honey, some gray and clear like ice, and some geode slices in stores so bright blue, bright pink, or deep purple that they almost do not look real? The most accurate answer does not come from just one element. The colors of a geode are the result of many factors working together. The type of mineral, trace impurities, crystal structure, oxidation state, formation conditions, the way light passes through the material, and sometimes even human treatment after the stone has been mined. A geode does not have one fixed color code. If the inside is mostly pure quartz, the color may be transparent or white. If the quartz contains many tiny inclusions, tiny cracks, or extremely small fluid bubbles, it may become cloudy white like milk. If it is amethyst, which means purple quartz, the color is connected to a very small amount of iron in the crystal structure and the effect of natural radiation over time. If there is calcite inside, the color may be white, clear, pale yellow, light brown, honey-colored, or many other shades, depending on impurities and growth conditions. If it is agate, the colored bands often reflect changes in the mineral-rich solution that passed through the hollow chamber many times. What we should avoid is saying too simply that this color definitely comes from this element, and that color definitely comes from that element. In mineralogy, color is rarely as simple as a paint chart. Iron can help create yellow, red, brown, or purple tones in many different mineral systems, but it does not always create the same color in every situation. Manganese can be connected to pink or purple colors in some minerals, but that does not mean every pink color in stone comes from manganese. The same element, when placed in a different structure or a different oxidation state, can create different color effects. And the same color seen by the eye can sometimes have many different mineralogical causes. Let us begin with quartz, because it is a very common mineral in geodes. Pure quartz is mainly made of silicon dioxide. When there are almost no impurities affecting the light, it can be transparent or nearly colorless. But in nature, quartz is rarely absolutely perfect. It can contain extremely small inclusions, tiny cracks, fluid bubbles, different growth zones, or very low levels of impurities. These factors can scatter light, making quartz look cloudy white, milky, lightly smoky, or slightly colored in another way. So a white geode is not boring at all. It can be the trace of light being scattered through countless tiny details inside the crystal. Amethyst is the most famous example of how a very small change can create very great beauty. In essence, amethyst is still quartz, but it is purple because the crystal structure contains traces of iron and because natural radiation can create color centers. These color centers make the crystal absorb part of the light in a way that causes our eyes to see purple. What is remarkable is that the amount of impurity needed is not large. Just a tiny change at the atomic level can turn a crystal chamber inside rock into a purple room. So a beautiful amethyst geode is not beautiful because it has been coated with color from the outside, but because its internal crystal structure interacts with light in a special way. The purple color of amethyst is not always even. Some specimens are dark purple at the tips of the crystals, but lighter near the base. Some have purple in zones. Some have only a few clear patches of color, while other areas are almost clear or white. This fits very well with how geodes form. The mineral-rich solution, impurities, growth speed, and radiation conditions are not necessarily the same in every spot. Natural color often has variation. It has stronger areas, lighter areas, and transition zones. That unevenness can sometimes be a more trustworthy sign than a color that is too perfect, too uniform, and too much like paint poured over the entire surface. Agate tells the story of color in a different way. Inside a geode, agate often appears as banded chalcedony. These bands may be white, gray, brown, light red, pale yellow, light pink, or many other natural shades. Each colored band may be connected to a different stage of mineral-rich solution. When groundwater carried a slightly different composition, the new layer left behind in the chamber could differ from the previous one. When there was a small amount of iron, the color could shift toward yellow, brown, or red. When precipitation conditions changed, the clarity, cloudiness, and thickness of the layer also changed. When we look at agate, we are seeing color as a sequence of time, not as a coat of paint. This is one of the beautiful things about geodes. Color can record changes in water. An agate band is not just a pretty line, it is the trace of a stage. If the layer below is lighter and the layer above is darker, that suggests the environment inside the chamber did not stay still. The mineral-bearing water changed. The impurities changed. The deposition speed changed. The time between layers may have changed as well. So a geode slice with many bands does more than please the eye. It shows us that the hollow space inside was visited many times by different flows of mineral-rich solution. Calcite also makes geode colors richer. Pure calcite can be colorless or white, but in nature, calcite can appear in many shades because of impurities or because of the way light moves through the crystal. Some specimens are pale yellow, honey-colored, light brown, gray, light orange, or almost transparent. Because calcite is softer than quartz and has a different crystal system, light on calcite also creates a different feeling. A quartz geode may sparkle with a cooler shine. A calcite geode may look softer, warmer, and almost like hardened honey. This helps us understand that color cannot be separated from crystal structure. The same light shines in, but each mineral answers that light in its own way. Iron is one of the elements people often mention when talking about color in rocks and minerals. In many cases, iron compounds, especially iron oxides or iron hydroxides, can create yellow, brown, red, or orange colors. These shades often make us think of rust, red soil, brown rock, or warm agate bands. But we need to be careful. Seeing red does not automatically mean the color definitely comes from iron, and iron does not always create red. The chemical state of the iron, the mineral that contains it, the grain size, its distribution through the rock layer, and the way light interacts with it all play a role. In a geode, iron may be only a very small part, but still enough to change the color feeling of an entire band. Manganese is another example of how trace impurities can create subtle color tones. In some minerals, manganese is connected to pink, purple, or dark brown-black colors. But just like iron, manganese should not be used as the only answer for every pink or purple color. The color of a mineral depends on the crystal structure the element is sitting in. The same element can create different colors in different minerals. So when we talk about geodes, the more scientific way to say it is this. Some trace impurities, which may include iron, manganese, or other elements, can contribute to color, depending on the mineral and the formation conditions. Color also depends on how light passes through the material. A thin layer of chalcedony may allow some light to pass through, creating a translucent look. A thicker layer may look more opaque. A clear quartz crystal can reflect strong flashes of light from its crystal faces. A druzy surface made of countless tiny crystals can scatter light into many sparkling points. An agate layer may not have a very intense color, but when it is cut and polished, light can enter and bounce back out, making the bands look clearer. So the color of a geode does not exist only in the material. It also exists in the meeting between material and light. This is why a geode can look very different before and after it is cut and polished. When it is still whole, light can barely enter. The outside surface is usually rough, gray, brown, or pale. After the geode is cut, the inside is revealed. After polishing, the agate layers may become clearer, the colors deeper, and the reflections stronger. Cutting and polishing do not create new minerals, but they help our eyes see the structure that was already there. It is like wiping dust off a window. The view does not suddenly come into existence, but it becomes easier to see. However, there is an important line to separate. Polishing to reveal natural beauty is different from dyeing to change the natural color. In the decorative stone market, many geodes and agate slices are dyed. Electric blue, bright pink, overly strong red, purple that is too even, or green that is too intense may be the result of human treatment. Dyeing does not turn the stone into plastic or make it completely fake. The stone and crystals can still be natural. But that color no longer honestly reflects the original geological history. It reflects an intervention after mining, meant to make the specimen more eye-catching, easier to sell, or more suitable for decoration. So when we look at a geode that is extremely bright, we should ask ourselves, was this color made by Earth, or was it added by people? Someone seeing a bright blue geode slice in a store for the first time may love it. That is normal. Strong color attracts the human eye. But as we learn more about geodes, we begin to love softer colors in a different way. A gray-white band in agate can speak of slowly precipitated silica. A light brown patch can suggest iron compounds. A milky white quartz area can show that light is being scattered by tiny internal details. An uneven purple shade in amethyst can reflect the uneven distribution of color centers. Earth usually does not create beauty in a perfectly artificial way. It creates beauty through variation, layers, traces, and uniqueness. So a cloudy white geode may sometimes have more scientific value in the eyes of someone who understands rocks than a bright blue geode slice that has been dyed. Not because blue is not beautiful, but because the cloudy white color may preserve the natural story of the specimen. It shows the real state of the silica, the crystal, and the hollow chamber. In science, truth matters more than attention. A soft, natural color may feel less dramatic, but it is more honest to the formation process. And when we are telling the story of an ordinary stone holding a universe inside, that honesty is what gives the story more depth. This also helps us look at color in geodes more calmly. We do not need to deny the beauty of dyed specimens, but we need to call them by the right name. A dyed geode can be beautiful as a decorative object. It can belong on a bookshelf, on a desk, or in a colorful collection. But if we want to understand geological history, we need to know which part is natural and which part has been treated. Natural color tells a story about water, minerals, impurities, and time. Dyed color adds another story about the market, taste, and human hands. Those two stories are different, and they should not be mixed together. Color inside a geode has another interesting feature. It is not always spread evenly through the chamber. One side may be darker than the other. The center may be brighter than the rim. Some crystals may have strongly colored tips while their bases are almost white. This distribution is often connected to how the crystals grew and how the mineral-rich solution touched each area. If one side of the chamber received a different flow of solution, the color may differ. If a crystal grew in stages, the newer part and the older part may not look the same. A geode can therefore be like a small map of water movement and chemical conditions inside the chamber. In large amethyst geodes, the purple color sometimes concentrates at the crystal tips. This gives the inner chamber a very special visual depth. Pale crystal bases, darker purple crystal tips, and the whole surface looking like a crystal forest touched by evening light. But this pattern of color distribution also reminds us that crystals have a growth history. They are not objects dyed evenly from the outside in. They grow from a surface, region by region, stage by stage. Color follows that process. When we see uneven color, we are seeing traces of growth. Another thing to remember is that color does not determine the entire value of a geode. A geode with strong color may be beautiful, but wholeness, crystal structure, naturalness, banding, geological origin, and preservation also matter. A specimen that has been dyed too strongly may lose some of its natural subtlety. A small specimen with less color but a clear structure and no treatment may be valuable for education. In science, a stone does not need to be the brightest one to be worth observing. Sometimes a simple specimen shows the process more clearly than an overly dramatic one. Imagine placing 3 geodes side by side. The first is milky white quartz, without strong color, but with crystals growing evenly from the chamber wall toward the center. The second is agate with brown-gray bands, each thin layer wrapping around the chamber like a ring of memory. The third is a dyed bright blue slice, very eye-catching under a lamp. At first glance, the third one may win, but if we slow down like scientists, the first two say more about Earth. They speak of silica, groundwater, natural impurities, deposition speed, and change over time. Their soft colors are not a weakness. They are the original handwriting of nature. The wonderful thing is that when we understand the chemistry, the beauty does not disappear. Many people worry that scientific explanation will make a stone feel less mysterious. But with geodes, the opposite happens. When we know that the purple of amethyst comes from quartz, trace iron, and natural radiation, the purple becomes even more special. When we know that agate bands are traces of changing mineral-rich water over many episodes, each line feels more like a page of history. When we know that reddish-brown color may be connected to iron compounds, we see the connection between a small stone and the chemistry of Earth's crust. Science does not take emotion away. It gives emotion roots. The color of a geode is therefore a beautiful lesson in scale. A rock chamber may be only the size of a palm, but its color is connected to things that are very small at the atomic level and very large at the geological level. A few iron ions can help change the way light behaves. A flow of groundwater can leave behind a band. A long stretch of time can give crystals enough opportunity to grow. A surrounding rock layer can protect the entire process in darkness. When a geode is opened, our eyes see the color in a single moment. But that color is the result of many levels of nature meeting one another. It should also be said that not every color in a geode is equally stable. Some natural colors can be affected by heat, strong light, or treatment. Amethyst can change color if it is heated strongly enough, and some types of colored quartz can change under treatment. This is why mineral collectors often care about the treatment history of a specimen. A geode does not only raise the question, what color is it? It also raises the questions, where did that color come from? And what has that color gone through after the stone was mined? The second question is often more important than the first. When we bring color back to the main takeaway of the whole journey, everything becomes very clear. On the outside, a geode is often silent, rough, and ordinary. Inside, color is not meaningless makeup. It is the result of minerals, solutions, impurities, and time. The white of quartz, the purple of amethyst, the reddish-brown of iron-rich agate, the honey color of calcite, and the sparkle of druzy are all ways the room inside the stone answers light. The outside does not say much. The inside speaks in color. If we look very slowly, we will see that color inside a geode does not need to be perfect to be beautiful. A slight color transition, an uneven purple area, a slightly crooked agate band, a cloudy white crystal, or a faint brown patch on the chamber wall can all be real traces. That is what makes a geode different from a mass-produced decorative object. In nature, imperfection is often evidence of process. A crooked band tells us the mineral layer did not settle evenly. A fading color tells us conditions changed. A clear area and a cloudy area existing together tell us that light is moving through the material in different ways. These details give the stone its own geological personality. So the next time you look at a colorful geode, do not only ask whether it is beautiful, ask what that color is telling you. Is it the color of nearly pure quartz, or a milky white created by scattered light? Is it the natural purple of amethyst, or purple that has been enhanced? Is it agate banding left behind by many episodes of mineral-rich water, or artificial color that soaked in after cutting? Is it the brown tone of iron compounds, or just dye added for sale? These questions do not make beauty dry or lifeless. They add depth to beauty. They turn a stone slice into a conversation between the human eye and the history of Earth. In the end, the color of a geode reminds us that tiny chemistry can create great beauty. A very small amount of impurity, a change in solution, a different oxidation state, a different crystal structure, a polished surface, or a different angle of light can all change the way we see the stone. But at the deepest level, the story remains the same. A geode is an ordinary stone on the outside, while inside is a room quietly built by Earth. Color is simply the way that room speaks when light finally enters. Now that we understand why the inside of a geode has color, the next natural question is this: where are these stones that know how to keep secrets usually found? The answer is not everywhere. Geodes are not spread evenly across Earth like sand on a beach. They need a fairly special geological recipe: the right kind of rock, an original empty space, mineral-rich water moving through, and enough time for minerals to settle inside. That is why one region may be full of rocks but have no significant geodes, while another region may be so famous that as soon as its name is mentioned, mineral collectors immediately think of crystal chambers hidden inside rough stone. If we think of a geode as a small room inside rock, then the place where geodes are found is the place where Earth once had the right conditions to build those rooms. Some limestone regions and ancient sedimentary rocks are rich in geodes because those rock layers can contain cavities, nodules, cracks, or areas where material has dissolved away. Groundwater moving through those layers carries silica, carbonate, and other mineral ions, then leaves behind chalcedony, agate, quartz, calcite, or other minerals inside the empty spaces. Some ancient volcanic regions also contain geodes, because gas bubbles trapped in cooling lava can later become places where crystals grow. So, geodes can form in both sedimentary environments and volcanic environments, but they always need one shared condition: there must be internal space for minerals to grow. One of the most famous regions is the Keokuk area near the Mississippi River, where the name Keokuk Geode has become familiar to many rock lovers. These geodes are often associated with ancient rock layers of the Warsaw Formation from the Mississippian Age, which belongs to a very distant period in Earth's history. They are not just beautiful stones to place on a shelf. They are remnants of an ancient geological environment, where sedimentary rock, groundwater, and silica came together to create chambers lined with minerals. When we hold a geode from this region, we are holding a very small piece of a rock layer that once belonged to a world far older than humans. What makes Keokuk geodes special is not only that they are beautiful, but that they have a clear geological context. They are often found in specific rock layers, not randomly in every kind of ground. Many specimens have a rough outer shell, sometimes nearly round or slightly distorted, with quartz, chalcedony, calcite, or other minerals inside. Some open to reveal only soft white crystals. Others contain more types of minerals. Some are clearly hollow, while others are partly filled. These differences make each one feel like a natural laboratory, where the conditions inside each chamber were not exactly the same. When geodes are found in stream beds or along riverbanks, that does not mean they formed there. Usually, the geode formed earlier inside a rock layer. Later, the surrounding rock weathered away. Rain, flowing water, temperature changes, and time weakened the host rock. Softer material was washed away or broken down, while the geode, with its more durable shell, could be released. A stream could then carry it, smooth its surface, and leave it among gravel and mud. So when someone bends down and picks up a rough, round stone from a stream bed, they may be picking up an object that has gone through two journeys: the journey of forming inside rock and the journey of being brought out by weathering. The broader Midwest also has many sites connected to geodes in ancient rock layers. Certain areas in Illinois, Iowa, Missouri, Indiana, and Kentucky are known among collectors for geodes, nodules, or mineral-filled cavities in sedimentary rock. However, this does not mean that anyone can simply dig into the ground and find geodes. Geology does not distribute itself according to what rock hunters want. The right rock layer has to be there. The right bed has to be there. The right groundwater history has to be there. And often, people also need to know which areas allow collecting. No one can look at a field and know for certain that geodes are underneath. It takes an understanding of geological maps, rock layers, landforms, and sometimes even local mining history. In Kentucky, geodes are often described as having an outer shell, while the inside may be hollow or partly filled with crystals. Many geodes there contain quartz, but they may also contain calcite, dolomite, and other minerals. This is important because it reminds us that the word geode does not always mean the same internal contents. One region may produce geodes that are mostly quartz. Another region may have more calcite. Some places produce small geodes, others produce larger ones. In some places, the bright crystals are the most noticeable feature. In others, the outer shell and inner lining are the parts worth noticing. Each region has its own geological recipe, and each recipe creates its own kind of secret. From sedimentary rock layers, we can move on to ancient volcanic regions, where large amethyst geodes have become iconic. Brazil and Uruguay are famous for large amethyst geodes, often connected to basalt in ancient volcanic provinces. There, cavities in volcanic rock can be lined with agate, quartz, and amethyst. Some geodes are so large that when they are cut open, they look like two purple stone doors, with the inside covered in crystals. Some specimens are nearly as tall as a person and extremely heavy, ending up in museums, mineral shops, or display spaces. But even though they are visually powerful, the basic principle is still the one we have already discussed: empty space, mineral-rich solution, crystallization, and time. With amethyst geodes from Brazil and Uruguay, the purple color is not only what makes them aesthetically famous, it also makes them a clear example of how local geology can create a mineral form recognized around the world. Ancient basalt flows cooled and created cavities. Later, silica-rich solutions and the right chemical conditions allowed agate, quartz, and amethyst to develop inside. Not every cavity in basalt becomes a beautiful geode. Not every geode in basalt is purple. But in places where the right conditions repeat on a large scale, a geological region can become a famous source for an entire type of geode. Mexico is another region that collectors pay close attention to, especially from many geodes, agates, and thundereggs. A small distinction is needed here. A thunderegg is not exactly the same as a geode in the sense of a hollow cavity lined with crystals, although beginners may confuse the two. A thunderegg is usually a nearly round nodule in volcanic rock, and it may contain chalcedony, agate, jasper, or crystals inside. Some have small cavities, while others are almost solid. They still serve our story very well because they show one thing clearly. In ancient volcanic rock, rough, round structures on the outside can hide completely unexpected mineral images within. In Namibia and some other dry regions, geodes, agates, and minerals formed in cavities also attract collector interest. Dry regions often have the advantage that rocks and minerals are easier to see because less vegetation covers the ground. But that does not mean geodes formed because of the present-day dryness. Their actual formation is connected to earlier histories of rock, water, and minerals. Today's climate may help people see or find specimens more easily, while the process that created the geodes usually took place in much longer geological settings. In some places in England, there are geode-like stones known by folk names such as potato stones, meaning rocks that look like potatoes on the outside but may contain quartz, calcite, or agate inside. Specimens connected with areas such as Somerset, Dulcote, Bristol, or other ancient rock districts are mentioned in collecting circles and mineral history. The name potato stone is wonderful because it captures the first impression of a geode perfectly. The outside may not look grand at all. It may even look rough and funny, like a stone potato, but when opened, the inside may contain crystals or mineral bands. That folk name almost summarizes the whole central point of the video. The most ordinary-looking thing can hold the most astonishing thing inside. Places such as quarries, cliffs, riverbanks, stream beds, and weathered areas often make geodes easier to expose. In quarries, humans cut into rock layers, revealing beds that were once deeper or hidden. Along rivers and streams, water can carry away softer material and leave harder stones behind. On cliffs, erosion can expose cross-sections of rock layers. But finding geodes is not only a matter of luck. Someone who understands geology will ask, does this area have suitable sedimentary rock? Does it have ancient basalt? Does it have nodule-bearing layers? Is there a history of groundwater carrying silica? Are there signs of weathering that could release harder masses from softer rock? These questions turn rock hunting into a way of reading the landscape. A beautiful geode does not represent only itself. It represents the land that created it. A geode from the Warsaw Formation tells the story of an ancient sedimentary system. An amethyst geode from South American basalt tells the story of volcanic rock, cavities, and silica-rich solutions. A potato stone from Somerset suggests rough stones that local people once recognized by their unusual appearance. A specimen from a quarry tells the story of a place where humans cut through rock layers and accidentally revealed old mineral chambers. When we place specimens from different regions side by side, we do not just have a rock collection. We have a small map of different geological processes. However, precisely because geodes are connected to specific places, collecting them also requires care. Not every place with rocks allows people to take them. Some areas are inside parks, protected reserves, private land, active mines, or regions with rules that protect geological resources. Some places allow small-scale collecting. Some require permits. Some prohibit collecting completely. This is not only a legal issue, it is also a matter of respecting geological sites. If too many people dig without control, a place that once had educational and scientific value can be damaged. Rock layers can be broken apart, landscapes can be disturbed, and specimens with scientific context can be removed without records. A geode in a store has usually already left its original context. We see its beauty, but we no longer see the rock layer where it sat, the surrounding rock type, its position in the geological bed, or its relationship to other specimens. For collectors, origin information is therefore very important. A specimen labeled clearly with its region, rock layer, mine, or country has more learning value than one labeled only as a natural geode. Origin is not just a sales label. It is the part that helps connect the stone back to its geological story. This is especially true with geodes famous by region. A Keokuk geode is not just any geode. It is connected to a geological region, a collecting history, and Mississippian rock layers. An amethyst geode from Brazil or Uruguay is not just a purple geode. It is connected to basalt and mineralization processes in volcanic cavities. Potato stones are not just strange rocks. They are connected to geological history and to the way local people named a mineral phenomenon. When we know where a geode comes from, we no longer see it as a detached object. We see it as a small piece of a larger landscape. Not all geodes from the famous region are equally beautiful. This is simply the reality of nature. One site may produce many specimens, but only a small portion may have beautiful chambers, clear crystals, attractive colors, or intact structures. Some are broken, some are completely filled. Some have only a very thin mineral layer. Some, when cut open, show nothing especially striking. In nature, a good region does not guarantee that every stone will be perfect. But this uncertainty is exactly what makes geode hunting so appealing. You are not only looking for a beautiful object, you are looking for an answer hidden inside stone. One interesting thing is that geode hunters often learn to read the outside, but the outside only gives clues, not guarantees. A stone that is nearly round, has a bumpy surface, a rough shell, and feels lighter than a solid rock of the same size may make someone suspect it is a geode. But no sign is absolutely certain. Some stones look very promising, but are solid or unimpressive inside. Others look unremarkable on the outside, but open to reveal good crystals. This allows a geode to keep its secret until the very last moment. And that fits its nature perfectly. The outside does not tell the whole truth about the inside. In regions where geodes occur in limestone or sedimentary rock, the presence of carbonate rock is important. Limestone can be dissolved by water over time, creating cavities or changing the internal structure. Nodules in sediment can be replaced by silica. Tiny cracks allow water to move through. If that water carries silica and the conditions are right, Chalcedony or quartz can appear. So when we hear that a place is famous for geodes in sedimentary rock, we should remember that we are hearing a story of ancient seas, ancient mud, ancient minerals, groundwater, and very slow replacement processes. In basalt regions, the story has a different rhythm. Basalt is volcanic rock that forms when lava cools. In lava, gas can create voids. Later, mineral-rich solutions move through these voids and leave behind agate, quartz, or amethyst. A dark basalt mass on the outside can contain bright crystal cavities within. The contrast is powerful. Black, heavy volcanic rock born from heat, with purple or white crystals inside, formed later through water and cooler processes. Once again, the geode shows us that beauty does not come from the surface, but from hidden history inside the rock. Desert or semi-arid regions can sometimes make geodes easier to find because less soil and vegetation cover the ground. But we should not confuse the conditions of discovery with the conditions of formation. A geode may have formed in a geological environment very different from the climate that exists today. A region that is dry now may once have had active groundwater. A rock layer now exposed on a hillside may once have been under an ancient sea or beneath a lava flow. The place where a geode is found today is the final chapter of exposure, not necessarily the whole story of how the geode was born. For science-loving viewers, the important point is that each place name is not just a name on a map. It is a combination of conditions. Keokuk makes us think of Mississippian rock layers and sedimentary geodes. Brazil and Uruguay make us think of basalt and amethyst. Mexico suggests agate, thunder eggs, and diverse volcanic geology. Somerset and its potato stones suggest rough stones carrying crystal secrets inside. Kentucky and other ancient rock regions show us that quartz, calcite, dolomite, or many other minerals can line a chamber. Each place is a different way for Earth to answer the same question. If there is an empty space inside rock, what can grow inside it? It is also worth remembering that geodes are not found only by going rock hunting in nature. Many geodes come from quarries, mineral extraction, or commercial sources where they have already been collected, cut, and sorted. When buying a geode, we should care about where it comes from, whether it has been dyed, whether it has been heavily treated, and whether the seller provides basic geological information. A specimen with a clear origin gives its story more completeness. A geode without origin can still be beautiful, but it is like a page from a book with the title and date missing. Over-collecting geodes can also have an impact. Some famous collecting sites can be heavily dug up, damaging the landscape or destroying scientific context. With rocks and minerals, context matters greatly. A geode sitting inside a rock layer tells us its position, its bed, and its relationship to the surrounding rock. When it is removed without documentation, it becomes a beautiful object, but loses part of its information. So the right approach is to respect the site, follow the rules, collect only modestly where collecting is allowed, and understand that a landscape is not just a storage room for decorative objects. It is an outdoor geological library. If we tell the journey of a geode from its birthplace to its display place, we see that it passes through many stages. First, a hollow space forms inside rock. Then, mineral-rich water enters and lines the inside with crystals. Then, the host rock weathers, allowing the geode to be exposed. Then humans find it, cut it, clean it, and sometimes polish it. Finally, it sits on a table, in a glass case, in a classroom, in a museum, or in the hands of a curious person. But no matter how far it travels, its geographic origin remains in its structure. Its color, minerals, shell, and crystal style are all fingerprints of the place where it was created. There is something beautiful about thinking of geodes on a world map. Many different lands can create the same basic idea. A hollow space in South American basalt, a nodule in an ancient rock layer in the Midwest, a potato stone in Somerset, an agate mass in Mexico. All of them are different in context, but they all show Earth's ability to turn empty space into a place with structure. Geology does not repeat every detail exactly, but it does have broad principles. When those principles meet local conditions, a geode appears as its own unique variation. So, when we ask, where are geodes found? The deeper answer is not just a list of place names. It is this. Geodes are found in places that once had the right kind of rock, the right empty spaces, the right flow of mineral-rich water, and the right weathering history to bring them into the light. They may be found in ancient limestone layers, in shale, in basalt, in quarries, in streambeds, along riverbanks, or in regions known to generations of collectors. But wherever they are found, geodes do not make themselves obvious from the surface. They need someone who understands the landscape, understands rocks, and sometimes has enough patience to open a stone that seems completely ordinary. And finally, a beautiful geode is not just a decoration. It is a small piece of local history. It carries signs of the rock layer where it was born, of the water that once moved through it, of the minerals that were transported, and of the climate and weathering that brought it out of the host rock. If we place it on a table and say, "This is a beautiful stone," we are right, but we have not said enough. More fully, it is a silent piece of earth, created by a specific landscape, hidden by time, and opened by light. On the outside, it may have an ordinary rough shell, but inside, it holds not only crystals, but also geography, history, and the unique recipe of the place it came from. When a geode leaves the rock layer where it was born, its story is not over. It simply enters another life, one closer to people. From a mineral chamber resting quietly inside stone, it can become a specimen in a classroom, a display piece in a museum, a collectible on a desk, or a quiet stone slice in a living room. But wherever it appears, the deepest value of a geode is not only in its beauty. It is in its ability to make geological time visible to the naked eye. Very few natural objects create such a clear feeling of surprise as a geode. A beautiful leaf shows its beauty right on the surface. A beautiful seashell usually shows its pattern on the outside too. But a geode is different. It begins with secrecy. Before it is opened, it may look like nothing more than a rough, grayish-brown, bumpy, slightly rounded rock, with nothing that makes the eye stop for very long. That is exactly why the moment a geode is opened has such strong educational power. It shows people that in science, observing the surface is only the first step. To understand nature, we have to ask what is inside, what process took place, and why the outside does not tell the whole story. In a classroom, a geode is a specimen that easily captures attention. When someone holds an uncut geode, they can describe the outer shell, weigh it in their hand, look at the surface, and guess whether it is hollow inside. Then, when the stone is safely cut or opened, the crystals appear. At that moment, ideas that may have sounded dry, such as minerals, crystallization, groundwater, silica, chalcedony, agate, quartz, or calcite, suddenly become concrete. Students do not just hear that mineral-rich water can move through rock. They see the result of mineral-rich water. They do not just hear that crystals have structure. They see crystal faces reflecting light. That is when geology stops being a word in a book and becomes something people can hold. A geode also helps explain a very important lesson. Crystals are not objects placed inside rock. They grow in place from mineral-rich solution when conditions are right. This is very useful when teaching crystallization. If we say that crystals grow as atoms or ions arrange themselves in an orderly way, listeners may find that abstract. But when we point to the inner wall of a geode and see crystals growing from the chamber wall toward the center, the lesson becomes easier to understand. The chamber wall is where material first begins to attach. The empty space is where crystals have room to develop. Each crystal point is a trace of that process. Breaking open a geode also has a special appeal, but it needs to be done properly. In many educational kits, small geodes are sold so learners can open them themselves, often with instructions for using a hammer, chisel, safety goggles, and a safe surface. The important thing is to understand that this is not just a fun activity, it is an observation experiment. Before opening it, we make a prediction. After opening it, we compare that prediction with the result. Is this stone hollow or more solid than expected? Are the crystals large or small? Is there an agate layer? Is the color natural or are there signs of treatment? A simple act like opening a stone can teach the habits of science. Observe, ask questions, test, and then adjust understanding. However, a geode should not be treated as something to smash just for fun. Each geode takes a very long time to form. Once it is shattered, we may lose its intact structure. If the goal is education, cutting a geode with the proper tools usually creates a better cross-section and preserves more information. If it is simply hit hard, the crystals may break, the bands may be lost, and the story inside can become harder to read. So the best way is to open a geode with respect. Open it to learn, not to destroy. In museums, a geode plays another role. It stands between science and emotion. A large geode, especially an amethyst geode, can make visitors stop for a long time. Children may see it as a purple cave. Adults may see it as an object that feels both familiar and strange. Rock on the outside, crystal order on the inside. A geologist sees it as a story about a hollow chamber, silica solution, basalt or sedimentary rock, and a history of mineralization. A good museum specimen does not only need to be beautiful, it also needs a clear information label: where it comes from, what its main minerals are, what kind of rock it formed in, whether the color has been treated, and what makes it worth noticing. In the living room, geodes are often used as decoration. Some people place two halves of a geode on a bookshelf. Some use agate slices as coasters, tabletops, lamps, or bookends. Some display a large amethyst geode as a focal point in a room. From an aesthetic point of view, this is completely understandable. Geodes have natural shapes, rich colors, beautiful reflections, and no two are exactly alike. They bring part of the mineral world into a living space. But even when a geode sits in a living room, it is still not only decoration. If we know its story, we see a small rock with far greater depth. Collectors love geodes because no two are identical. Two geodes from the same region can still differ in shell texture, hollow space, chalcedony thickness, agate banding, crystal size, color, accessory minerals, and level of preservation. A beginner may be drawn to the largest specimen or the brightest color, but experienced collectors often look at more factors. They consider whether the origin is clear, whether the specimen has been dyed, whether the crystals are damaged, whether the natural shell remains, whether the cut surface is attractive, whether the mineral is unusual for that type of geode, and whether the specimen still keeps its geological story or has become only an over-processed stone slice. The value of a geode, therefore, does not depend only on size. A large geode can make a strong impression, but if the crystals are damaged, the dye is too intense, the origin is unclear, or the internal structure is not especially interesting, its educational value may not be high. On the other hand, a small geode with clear minerals, beautiful agate layers, intact crystals, natural color, and carefully recorded origin may be more valuable. In science, the information that comes with a specimen matters greatly. A beautiful stone with no known origin is like a page torn from the larger book of Earth. A cut and polished geode slice can be very beautiful, but that does not necessarily mean it has higher scientific value than a rough, unopened specimen. A rough specimen preserves the natural surface, outer shape, weathering marks, shell, and sometimes even information about how it sat in the host rock. A polished cut helps us see the inside clearly, but it can also lose part of the context. So in serious collecting, both rough and cut specimens have their own value. A rough specimen keeps the question. A cut specimen gives the answer. A good collection sometimes needs both, an unopened stone to understand the outside, and an opened one to see the world inside. Natural geodes may also go through many treatments before reaching a buyer. They may be machine cut, polished, cleaned with solutions, stabilized to prevent breakage, or dyed. Some treatments help preserve and present the specimen better. Cutting and polishing can make agate bands clearer and help crystals reflect light more beautifully. Cleaning can remove soil or coatings that hide the crystals. But dyeing needs to be clearly stated. If a geode has been dyed electric blue, bright pink, too even purple, or overly strong red, it may still be real stone, but that color is no longer a natural record of the mineral chamber. A buyer should ask one very simple question. Has this specimen been dyed, heat-treated, stabilized, or coated? This question does not take away the beauty of the geode. It simply helps us understand it correctly. If we are buying for decoration, a dyed specimen may still make a room look more beautiful. But if we are buying to learn, to build a scientific collection, or to tell a geological story, natural color and clear origin matter much more. A geode with soft, uneven color and even some natural flaws may be more honest than a dazzling slice that has been altered to attract the eye. The most important thing to avoid is assigning geodes powers that do not have scientific evidence. A geode can be beautiful. It can make a space feel calmer emotionally. It can help a viewer feel focused, curious, or relaxed because of its natural beauty. But we should not say that geodes can heal illness, change the body's energy, remove toxins, cure insomnia, or have medical effects without reliable evidence. A scientist can deeply appreciate a geode without giving it supernatural powers. The real beauty of a geode is already great enough. It lets us see geological processes with the naked eye. That does not mean geodes have no emotional value. On the contrary, their emotional value is very real, as long as we name it correctly. One person may feel peaceful while looking at tiny quartz crystals because that surface suggests order. Another person may feel warmth when looking at golden brown agate because the bands resemble rings of time. Someone may place a geode on a desk because it reminds them that deep things are not always visible from the outside. These feelings are real, but they belong to aesthetic experience, personal memory, and reflection, not to medical evidence. A geode can also be a very meaningful gift if the giver understands its story. Giving a geode is not just giving a beautiful object. It can say, "This is a stone that looks ordinary on the outside, but inside, it holds a world created by time." That meaning is much more human and much more grounded than exaggerated claims. It reminds us that people also have inner layers that cannot be seen immediately. But when we use this image, we should keep it as a metaphor and not turn the geode into an object with powers that science has not confirmed. A metaphor can be beautiful without being untrue. In family education, a geode is a wonderful way to begin a conversation with children or with anyone new to science. One geode can lead to many questions. Why is the rock hollow? How did water get inside? Where did the crystals grow from? What is quartz? Why is there purple? Why are there bands? Why is the outside plain while the inside is beautiful? Each question is a doorway. From a geode, we can enter mineralogy, chemistry, geology, groundwater, deep time, weathering, mining, conservation, and even the ethics of collecting. A small stone can open an entire map of knowledge. In the laboratory or classroom, a geode also helps learners distinguish between observation and interpretation. Observation is this: there are white crystals inside, a rough outer shell, gray bands, and a hollow space in the middle. Interpretation is this: the crystals may be quartz, the bands may be chalcedony or agate. The hollow space shows that crystals had room to grow, and the shell may be more durable than the surrounding rock. Science begins with accurate observation, then interprets based on knowledge. A geode is a good specimen because it offers many details visible to the naked eye, but it is still complex enough to require knowledge for explanation. In collecting culture, geodes also teach patience. A beginner may want to open every rock that might be a geode right away. A more experienced collector usually moves more slowly. They study the shape, listen to the sound when it is tapped gently, observe the surface, learn about the location, and then decide whether it should be cut or kept whole. Some stones are most beautiful when cut in half. Some should remain whole because their natural shape is unusual. Some need to be cut by machine to avoid breaking the crystals. Some are not worth opening because the geological information or outer shape is already interesting enough. Collecting geodes is not only about owning objects. It is also about learning how to make decisions with respect for the specimen. Another practical point is that geodes can be faked or described incorrectly. In the market, there are natural specimens, dyed specimens, assembled specimens, specimens with added material, and specimens given names that sound more exciting than the reality. Some sellers may call any rock with crystals a geode, even when the geological structure is not quite right. A solid agate specimen may be called a geode. A thunder egg may be sold as a geode. A crystal-bearing rock of another kind may be described vaguely. This is not always intentional deception, but buyers should learn to ask clearly, what is the main mineral? Where does the specimen come from? Is it natural or treated? Does it have a real hollow chamber? Is the name accurate? For science lovers, using the right name is part of respect. Geode, nodule, thunder egg, vug, druze, agate, chalcedony, quartz, and calcite are not words that make the story unnecessarily complicated. They help us see more clearly. A vug is a cavity in rock lined with crystals, but it is not necessarily a separate, nearly round mass like a geode. A thunder egg may be a nodule in volcanic rock, often containing chalcedony or agate, and sometimes containing a cavity. Agate is banded chalcedony. Quartz is a mineral with its own crystal structure. When we use the right names, we do not remove the poetry. We make the poetry stand on accurate ground. In modern life, geodes appear often in interior design. Thin agate slices may be backlit to show their bands. Large geodes may be placed in a room like natural sculptures. Small geode halves may become bookends or desk decorations. But when we bring a geode into the home, we should also remember that it is a natural material that comes from mining. A large specimen has been taken from the ground, transported, cut, polished, and sold. Beauty in the living room always has a story behind it, a story of geology, labor, trade, and consumer choice. This does not mean we should not display geodes. It only means we should display them with understanding. A geode placed in a home can be a reminder of deep time, of nature's patience, and of things that cannot be seen immediately from the outside. If it has a small label showing its origin and minerals, it can also become a learning point for guests. Instead of simply saying, "This one is beautiful," we can say, "This one has agate and quartz layers, and it formed when mineral-rich water entered a hollow space in rock." A single sentence like that can turn a decoration into a scientific story. Geodes also help us understand the difference between aesthetic value and scientific value. A brightly dyed stone slice may fit a modern room very well. That is aesthetic value. A rough specimen from a clearly recorded site with unusual minerals or a special structure may not be as eye-catching, but may have higher scientific value. A small geode used in a classroom may be inexpensive but very effective for education. A large geode displayed in a museum may combine both aesthetics and science. When we understand that these types of value are different, we do not judge a geode only by price or color. A small geode can tell a story larger than many expensive decorations. Inside it is a real chain of processes. An empty space forms in rock. Mineral-rich water enters. Chalcedony layers settle. Crystals grow. The host rock weathers away, the specimen is found, and then people open it and observe it. A human-made object can be very beautiful, but it usually does not carry deep time in that way. A geode has a special kind of depth. It is a small object that connects us to Earth's history. When we hold it in the palm of our hand, we are holding part of a natural process that took place for a very long time without needing any human witness. That is why a geode is a bridge between science and emotion. Science tells us what it is, how it formed, what minerals it contains, where its colors come from, and why each region has different kinds of geodes. Emotion gives us a reason to look longer. If we have emotion without science, we may fall into exaggeration or believe things that have not been proven. If we have science without emotion, we may miss the very human sense of wonder that comes from seeing a crystal room inside a rough stone. A geode is most beautiful when these two things go together, understanding it correctly and still being able to feel amazed. Perhaps that is why geodes so easily make people pause. They create a clear shift between outside and inside. Before opening, the stone is ordinary. After opening, it has depth. That shift is almost a philosophical lesson, but it does not have to leave science. It says that the surface is not the whole truth. It says that time can work in silence. It says that an empty space, if it meets the right mineral-rich water and the right conditions, can become a place where crystals grow. And it says that natural beauty sometimes has to be discovered not because it is trying to hide, but because it was born in places the human eye cannot see right away. In a quiet room, imagine someone holding a geode that has been cut in half. On the outside, a rough shell remains around the edge. On the inside, there is the light of quartz, the bands of agate, or the purple of amethyst. That person may not be a geologist. They may simply be someone who likes a beautiful object. But if they know that this chamber was once an empty space, that water once moved through it, that minerals once settled there, and that crystals once grew in darkness, then the moment of looking at the stone becomes deeper. Knowledge does not make the geode less beautiful. Knowledge gives the beauty weight. One precious thing about a geode is that it does not need many words to spark curiosity. Just place one unopened geode and one opened geode side by side, and people will ask, how can the outside and inside be so different? From that question, we can go very far. We can talk about volcanic rock and gas bubbles. We can talk about limestone and cavities. We can talk about groundwater and silica. We can talk about the purple of amethyst, the bands of agate, and the crystals of calcite. We can talk about rock collecting laws, site conservation, and the difference between natural color and dyed color. One small question opens many layers of knowledge, but whether a geode enters a classroom, a museum, a shop, or a living room, we should still keep this central message. It is an ordinary stone on the outside, but inside is a world slowly built by Earth through water, minerals, and time. Humans arrive later. Humans find it, cut it open, polish it, display it, study it, collect it, and name it. Humans can make a geode easier to see, but they do not create the history inside it. The deepest part of a geode belongs to Earth before it belongs to us. And perhaps that is the best way to live with a geode. Do not turn it into a magic charm. Do not reduce it to a simple decoration. And do not look at it coldly as a lifeless specimen. Let it be exactly what it is: a small geological structure, a lesson about groundwater, an example of crystallization, a beautiful object, a piece of local history, and a gentle reminder that something ordinary can hold great depth inside. When seen this way, a geode does not need to say anything. It simply rests there, letting its rough shell and inner crystal chamber tell the same story together. After going through their origin, minerals, colors, locations, and the ways people live with geodes, we can now look at the more special ones, the cases where a stone no longer feels like a small object on a table, but almost becomes a world of its own. Some geodes fit in the palm of your hand, light enough to slowly turn under a lamp. Some are so large that specialized cutting machines are needed to open them. Some amethyst geodes are nearly as tall as an adult and are called cathedral geodes because, when cut open, their shape resembles a church arch made of purple crystals. And there are also giant crystal chambers underground, large enough for people to step inside. But when we talk about them, we need to be very careful. Not every crystal cave is a geode in the usual sense, and not every large geode is the same as the small ones sold in stores. A small geode can fit in your hand, but it can still contain the complete story of a large geode: an outer shell, an empty or partly hollow interior, minerals lining the chamber walls, and crystals that developed over time. Small size does not make it less important scientifically. A geode only the size of an egg, but with clear agate layers, natural quartz crystals, undyed color, and well-recorded origin, can still be more valuable than a large specimen that has been heavily treated, badly broken, or has no clear source. In geology, value does not only come from being overwhelming. Value comes from the story the specimen is still able to preserve. Some small geodes, when opened, have only a layer of tiny crystals coating the inside. They do not have large crystals like the ones in advertisements, but they are beautiful in a quieter way. When light falls on the druzy layer, thousands of tiny crystal faces reflected back like stardust. Each crystal face is very small, but together they create a lively surface. A geode like that shows us that Earth does not need to create something enormous to surprise us. Sometimes a small chamber, a fine quartz layer, and light hitting at the right angle are enough to turn a rough stone into a tiny sky. Some geodes contain quartz as clear as ice. When we look inside, we see transparent crystal points growing from the chamber walls, like ice columns frozen in the middle of their growth. But they are not ice, and they are not frozen water. They are silicon dioxide arranged into a crystal structure. If there is enough space, quartz can form clear crystal faces. If there are many tiny inclusions or very fine cracks, it can become milky white. So even within the same mineral family, geodes can take on many different looks: clear as glass, cloudy as milk, gray as smoke, or sparkling like mist. Some geodes contain calcite with shapes very different from quartz. Calcite can form rhomb-shaped crystals, blocky crystals, pointed crystals, or forms that collectors often call dog tooth, when the crystals look like small pointed teeth. In some large amethyst geodes, calcite can be seen growing on top of quartz or from the chamber walls. The presence of calcite changes the entire feeling of the inner room. Quartz often gives an impression of hardness, brightness, and sharp edges. Calcite can look warmer and softer in the light, sometimes honey-colored or clear white. The chamber is still a stone chamber, but when the mineral changes, the architecture inside changes too. Some geodes have almost no large crystals and are mostly agate. If we only enjoy strong sparkle, we may pass over them too quickly. But if we look like geologists, agate is a very valuable part of the story. The curved bands of Chalcedony along the chamber walls show many episodes of mineral-rich solution passing through. Each layer is a rhythm. Each colored band is a small change in chemistry, impurities, or deposition conditions. An agate geode may not shine as brightly as amethyst, but it is like a very clear record of time. It does not speak through glare. It speaks through bands. There are also geodes that have broken naturally. Part of the inner chamber may be exposed before any human cuts it. The edges may be worn down by water, wind, or impact. Specimens like these may not be perfect for display, but they are very close to the real life of rocks in nature. They show that geodes do not always appear as two beautifully polished halves. Before entering a shop, a geode may have been lying in soil, in a stream, in broken rock, in dust, in rain, and in a long process of weathering. A naturally broken geode can still have its own beauty because it shows both the inside and the traces of the journey outside. But then there are geodes so large that they change our sense of scale. Amethyst geodes from basalt regions in Brazil and Uruguay can be very large, sometimes reaching several yards long or a few meters. When they are cut open vertically, they look like purple arches, with dark rock or agate on the outside and amethyst crystals covering the inside. Tall, narrow specimens are often called cathedral geodes because they resemble the arched doorway of a quiet church. That name is commercial and aesthetic, but it also describes the feeling well. Inside the stone, purple crystals rise like natural architecture. In large amethyst geodes, we can often see many formation layers clearly. On the outside, there may be basalt or host rock. Inside, there may be a layer of sedimentary, chalcedony, or agate, then colorless quartz, and finally, amethyst in the more distinct crystal area. Not every specimen has the exact same complete set of layers, but the principle of multiple stages is very important. An amethyst arch does not appear in a single moment. It is the result of an empty chamber, chemical changes, silica-rich solution, temperature, impurities, and crystal growth over time. When we look at a large purple geode, we are seeing many geological layers opening before our eyes. Even so, large size is not the only measure of value. A large geode can impress us immediately, but if the color has been treated, the crystals are damaged, the origin is unclear, or the structure has been altered too much, it is not necessarily more valuable than a small natural specimen. On the other hand, a small geode that is undyed, has intact crystals, and carries a clear geological story can have high educational value. This is important because people are often drawn toward what is big, bright, and rare. But in science, the most valuable thing is evidence that remains intact and can be understood. Some large geodes are cut open for display in museums, mineral shops, or interior spaces. Cutting them open allows viewers to see the chamber inside, but it is also an irreversible decision. Once it is cut, the stone is no longer in the same state it had in nature. However, if it is cut properly, the cross-section can show the structure very clearly. The shell, the agate layer, the crystal zone, the hollow space, and the growth direction of the minerals. A well-cut large geode is like a cross-section of history. It does not only show off beauty, it reveals how that beauty was built. Giant crystal chambers, such as the Pulpi geode in Spain, take the story to another level. This is a large chamber inside Minarica in the Almeria region, discovered in 1999, famous because its interior is covered with transparent gypsum crystals, with some crystals reaching up to about 6.5 feet long, or about 2 meters. The chamber is about 26 feet long, or about 8 meters, and about 6.5 feet tall, which is about 2 meters, large enough for people to call it one of the most remarkable geodes in the world. But the important point is not only its size. The important point is the transparency, completeness, and scale of the gypsum crystals inside the chamber. Here, the stone with a universe inside almost becomes a real room of crystals. When talking about Pulpi, we need to clearly distinguish the mineral. This is not an amethyst geode. It is famous for gypsum, which is hydrated calcium sulfate, not purple quartz. Gypsum is much softer than quartz and has different mineral properties. The crystals in Pulpi are transparent, large, and formed in a special geological environment connected to underground solutions. This reminds us that geodes are not limited to one single mineral. A small geode in a shop may contain quartz. A large geode in South America may contain amethyst. Pulpi shows us a giant gypsum chamber. Each case is its own chapter in the same book about hollow spaces and minerals. However, not every large crystal cave should be called a geode in the narrow sense. Some caves or cavities in mines contain giant crystals, but they are not like the nearly round geodes we usually see in collections. A crystal cave may be a large chamber system in rock or in a mine, formed through hydrothermal processes, dissolution, crystallization, and complex geological change. It may be extremely beautiful, but it still needs to be named correctly. Calling it correctly does not take away its grandeur. On the contrary, it helps us respect the differences among geological phenomena. This is similar to distinguishing a small geode, a thunder egg, a vug, a crystal cave, and a mineral chamber in a mine. All of them can contain crystals. All of them can amaze viewers, but their shapes, origins, sizes, and geological contexts are not exactly the same. A typical geode is usually a separate or nearly separate rock mass with a mineral-lined chamber inside. A vug is a cavity in rock lined with crystals, but it is not necessarily a separate rounded object. A crystal cave may be a large chamber people can enter. When we make these distinctions, the story becomes more accurate and the beauty remains intact. Some geodes give no warning from the outside about what is inside. This is one of the truths that makes them so fascinating. A tall amethyst arch may look magnificent when displayed, but before it was cut, it still had a rough outer rock layer. A small geode in a stream bed may be covered in mud and look no different from an ordinary stone. An agate specimen may only reveal its beauty after being polished. A quartz geode may need light from the right angle before its druzy surface begins to glow. So a geode always keeps part of the surprise. It is not an object that shows everything from the beginning. It asks people to open, observe, and be patient. Every geode is a geological experiment that cannot be repeated in exactly the same way. We can describe the general rules: hollow space, mineral-rich water, precipitation, crystals, and weathering. But each specimen has its own chamber shape, lining thickness, minerals, colors, cracks, and history of contact with water. Even two geodes from the same rock layer are not completely identical. This makes them like pieces of music written on the same theme, but each with its own rhythm and tone. The rules are shared, but the result is individual. A special geode does not necessarily have to be rare in the expensive sense. It can be special because it preserves one clear detail: a beautiful agate layer, a calcite crystal growing at an angle, a balanced hollow chamber, uneven natural color, a glass-clear quartz zone, or one naturally broken half that shows the weathering process. When we observe long enough, we learn that what is special in geology is not always found in spectacle. Sometimes it is found in a small but truthful trace. A curved band, an imperfect crystal face, or a thin mineral layer at the edge of the chamber can all be worth reading. When humans open a geode, we do not create the beauty inside it. We only discover what has quietly existed there. This point should stay very clear. Cutting, polishing, or lighting can make the beauty easier to see, but those things are not its origin. The origin lies in the hollow chamber, in mineral-rich water, in chemical conditions, in time, and in the persistence of crystals. A craftsperson can cut the stone into two beautiful halves, but that craftsperson did not place each crystal there. Earth did that work long before the stone ever reached human hands. Perhaps that is why geodes can feel almost sacred, even though we do not need a supernatural explanation. They show a kind of beauty that was not created for our eyes, but one day meets our eyes anyway. Crystals grow in darkness. Agate forms bands inside a sealed chamber. Quartz grows according to crystal faces. Calcite develops according to its own geometry. Gypsum in pulpi opens like a transparent forest underground. There is no audience while they form, but when they are seen, they remind us that nature is not only great in mountains, oceans, continents, canyons, or glaciers. Nature is also great in small, hidden chambers. A geode is evidence that Earth does not only create volcanoes, oceans, continents, canyons, or ice sheets. Earth also creates small rooms of light. Some rooms are small enough to fit in the palm of your hand. Some purple rooms are nearly as tall as a person. Some gypsum chambers are large enough that people must enter with caution and respect. At every scale, the same idea appears. Inside rock, there can be space. Inside that space, there can be water. Inside that water, there can be minerals. And from those minerals, time can create crystals. But geodes also remind us that beauty needs protection. Large crystal chambers can be easily damaged if they are touched, sampled carelessly, exposed to changes in humidity, or vandalized. Crystals may look hard and motionless, but many minerals are very sensitive. Gypsum is softer than quartz and scratches more easily. A broken crystal cannot simply grow back within a human lifetime. That is why places like Poulpi are not only tourist attractions, they are geological heritage sites that need careful management. The more special something is, the more respectfully it should be seen. With small geodes, that same respect should also exist. We should not treat every geode as something to break open casually. We should not dye a specimen and sell it as natural without saying so clearly. We should not take rocks illegally from protected places. We should not forget the origin of a specimen. The most beautiful geode is not simply the brightest one. It is the one that still keeps its truth. Where it came from, what minerals it contains, whether it is natural or treated, how it was opened, and how much of its original structure remains. When we respect the truth, a geode becomes beautiful in a more lasting way. As we move from a small geode on a table to a large crystal chamber underground, the sense of wonder grows, but the message does not change. An ordinary stone can contain a world inside. That world does not need to be as wide as the sky to amaze us. Just an inch or two of hollow space, or a few centimeters, a few layers of chalcedony, a small cluster of quartz, and a soft agate band are enough to make geological time visible. And if that chamber is larger, if the crystals are longer, if people can stand before it as if standing before a crystal room, then what we are seeing is still the old principle magnified. Water, minerals, and time have worked in darkness. The final lesson of special geodes is not that only big things are valuable. The lesson is that every geode, whether small or large, is its own geological event. A small one can teach us about crystals. An agate one can teach us about layers and solutions. A large amethyst geode can teach us about basalt, silica, and the purple color of quartz. Poulpi can teach us about gypsum, large chambers, and the preservation of geological heritage. All of them return to the same point. The rough exterior is only the book cover. The inside is the story written in minerals. The inside of stone is not magic, but it can astonish us like magic. It is the physics of hollow spaces, the chemistry of mineral solutions, the geometry of crystals, the slowness of time, and the patience of earth. When a geode is opened, we do not only see quartz, agate, calcite, amethyst, or gypsum. We see something deeper. Sometimes the most precious things need darkness in order to form, need an ordinary shell in order to be protected, and need a great deal of time before the first light touches them. Tonight we have traveled through a journey that is very small in size, but very large in time. We have looked at a geode not only as a sparkling decoration, but as a geological record written by Earth in minerals. We have seen that it begins with an empty space inside rock, perhaps a gas bubble left behind in volcanic rock, or a chamber formed in sedimentary rock. Then, mineral-rich groundwater moves through tiny cracks, leaving behind layer after layer of chalcedony, agate, quartz, calcite, or amethyst. Every layer, every band, every crystal is a trace of a condition that once existed in darkness. And perhaps the most beautiful thing a geode leaves with us is not only the light inside it, it is the lesson that Earth does not rush. A stone can rest quietly for millions of years, rough and ordinary on the outside, while inside it silently protects a crystal room. When the stone is opened, we do not create that beauty. We only discover something that has been there for a very long time. We see that water once passed through. We see that minerals once settled. We see that time has taken shape. If you are still listening at this point, let that image stay gently in your mind. An ordinary shell does not mean there is no depth inside. An empty space is not always a lack of something. Sometimes that very emptiness is where crystals can grow. And sometimes the most precious things need darkness, silence, and a great deal of time in order to be protected. Now, our journey with geodes comes to a close here. Let your mind settle like the outer layer of a geode, calm, steady, and in no need of hurry. And let something inside you become softly bright, like tiny crystals slowly grown in silence. Sleepy Drift into Knowing wishes you a very good night's sleep. I will see you again on the next journey, where we will continue listening to the very slow, very deep, and very beautiful stories of Earth.